Okay, sorry, I got cut off there. So here's the full results here. So limit properties. So let's take my highlighter and underline some things here. Okay, so suppose that an goes to a. Okay, that's what I'm saying. The limit of an is a, and bn goes to b. So in other words, I'm saying that. Okay, then, so if you have a constant multiple, so part A here, if you have a constant multiple, k is, a real number. Then the limit of kan does what you expect it would do. Okay, then you have, the sum of sequences goes to the sum of limits, and also the same for differences. Products behave as expected. And finally, quotients do give you what you'd expect, but you have a few conditions. Okay, so if you haven't paused already, you may want to pause and write all this down. And I'm going to move the screen up now, and we will do some examples to illuminate. Let's shrink this a little bit so I have some room. Okay, so some examples. Imagine you have an is equal to 1 over n minus 1 over n squared. Okay, 1 over n certainly goes to 0, and 1 over n squared goes to 0 as well. So therefore, by the properties mentioned above, an goes to 0 minus 0, which is 0. Easy enough. If you have something like 2 to the n plus 3 to the n over 3 to the n, to see what's happening here, I'm going to break it up first of all. So I break it up and simplify a bit. So I'm going to think of this as a sum of sequences. So as we've seen before, we have r is 2/3, and the absolute value of r is less than 1. So that first bit is going to 0, and the second bit is just 1, 1, 1, 1, 1. So in the end, we get 0 plus 1, which is 1. Okay, how about a couple exercises here? You can think about. So you may want to pause there and think about the answer there. Okay, I'll do the answer now. So for this one, I could use my theorem above there. I could use the theorem at the top here if I wanted to. and then invoke L'Hopital's rule. Instead, I'm just going to break this up. This is 1 over n plus 1, which goes to 0 plus 1, which is 1. Here we get 2 over 3 to the n plus 4 over 3 to the n. This is convergent and this is divergent, since r is less than 1 here in absolute value and r is bigger than 1 in absolute value. Okay, why don't I put this little theorem here? Rn goes to 0 if the absolute value of r is less than 1. Rn goes to 1, if r equals 1, Rn diverges otherwise. Okay, let me just stare at that for a second to make sure I got that right. Yep, and equal 1, you get and if Rn is, yeah. Okay, so this is the thing you should memorize. I hope that makes sense to you. Okay, back to our exercise. So we have a convergent part here and a divergent part here. So overall, we must conclude that this is divergent. Okay, because again, Bn is a convergent part plus a divergent part. And I hope you agree that that means that it must be divergent overall.